Welcome to 8.2. Within this section, we are going to review the last 3 slides of this section, which truly incorporate all the different things that have been spoken about in reference to finding the domain, the range, horizontal and slant asymptotes, x and y intercepts, vertical as well as horizontal asymptotes, any crosses that may occur, and how they are all consolidated into a problem itself. We are going to review slides 5, 6, and 7. Here we have slide 5. Now, generally, whenever we take a look at one of these problems, there is a specific order that I would suggest that you take. And generally, that is starting off with our domain first, then leading into determining the whole, as well as the vertical asymptote. Next, you'll go into your horizontal or slant asymptote, followed by the cross, x and y intercepts. And it's at this point that you would then begin to graph. From your graph, you would be able to once again go back into your domain to verify that everything is accurate, your domain, your range, your end behavior, as well as your one-sided limits. So let's first begin with our domain. When we are looking at our domain, we are first going to break down our original equation. Now this right here is our original equation, and we're going to break it up into its factors. So in this case, this top numerator would be 3x times x minus 4, and our denominator would be x minus 3, x plus 1. In this case, there is nothing that will be able to break down, which means this will just simplify to 3x times x minus 4 over x minus 3, x plus 1. Now, in order to determine the domain, we are mainly going to look at the original equation, and we are going to look at the denominator. In this case, x minus 3 is equal to 0, which means x cannot equal 3, and x plus 1 is equal to 0, which means x cannot equal negative 1. So as we write down our domain, x such that x cannot equal negative 1 or 3. It's extremely important to realize that our domain can possibly change depending on some of the various answers that we find from this point forward. Now, as we try to go ahead and simplify towards that right-hand side of the equation, you can see that nothing does break down. Because of the fact that nothing breaks down or simplifies, this means that there is not a whole, so the whole would be none. The vertical asymptote in this case would be determined from our simplified equation. And that's what the right-hand side equation is. Now, in this case, like I said before, nothing simplified down, but if it did, you would get your vertical asymptote from the simplified equation's denominator. You would set it equal to 0, and that would be our vertical asymptote. In this case, our vertical asymptote would be x is equal to negative 1, and x is equal to 3. As we begin to go into horizontal and slant asymptote, it's extremely important to know your rules. Keep in mind, in order for it to be a slant asymptote, the numerator leading exponent, which is a 2, must be greater by 1 against the denominator. In this case, they are both equal to each other, which means automatically we know that this is not a slant asymptote. It is, on the other hand, a horizontal asymptote. So we would go ahead and write down our leading coefficient, in this case, which would be 3 over 1, which means that our horizontal asymptote would be y is equal to 3. We then go into our cross asymptote. Now here we are going to figure out whether that cross asymptote occurs or does not occur. In order for us to determine this, we have to go ahead and set our horizontal asymptote, which is 3, equal to our equation, or technically our simplified equation. Now in this case, our simplified equation is the same as our original equation, so it does not truly matter which one we decide to use. So as we go ahead, this would be 3x squared minus 12x over x squared minus 2x minus 3. And we're going to go ahead, multiply both sides by x squared minus 2x minus 3 in order to remove it from the denominator. Keep in mind, this and this would cancel out. We are left with 3x squared minus 6x minus 9 is equal to 3x squared minus 12x. We're going to bring our terms all over to one side. So we are going to subtract 3x squared and add 12x. When that occurs, notice our 3x squared cancels out, and we are left with 6x minus 9 is equal to 0. As we simplify this out, 6x is equal to 9. X is equal to 3 over 2. Well, originally, it would be 9 over 6, which simplifies to 3 over 2. Now, in this case, we have determined that our x is equal to 3 over 2. We go ahead, and as we go ahead and plug it back into our equation, we come up with a final solution of our whole being at 3 over 2, comma 3. Now, as we head back into our x and y intercepts, let's first start off with our y-intercept. Our y-intercept is whenever x is equal to 0. So in this case, because our equation was never originally simplified and nothing crossed out, we can still use the original equation. Keep in mind, as we start plugging in zeros for each one of the x, that would leave our numerator with 0 minus 0 over 0 minus 0 minus 3. 0 over negative 3 is just 0. So in this case, our y-intercept would be 0, 0, which also means that our x-intercept would have to be 0, 0 as well. We are still going to continue to do the x-intercept, and the main reason for this is to make sure that we have all of the x-intercepts determined just in case. In order to determine the x-intercept, remember we will set our y equal to 0. Now, as we did that before, in this problem we set it equal to 3 before. But in this case, for the x-intercept, we would set it equal to 0. So we would go ahead and say 0 is equal to 3x squared. Or we can even use the simplified equation, 3x times x minus 4 over x minus 3, x plus 1. Keep in mind, anything multiplied by 0 would give us 0. So we would end up with 0 is equal to 3x times x minus 4. So 3x is equal to 0, x is equal to 0, x minus 4 equals 0, x is equal to 4. So in this case, we are missing one x-intercept, which would also be at 4, 0. At this point, this is the best location and the best time to go ahead and start writing down all of the values that we have. So we're going to go ahead. We start with our asymptotes. We have a vertical asymptote at -1 and 3. So vertical asymptote at -1 and 3. We also have a horizontal asymptote at y equals 3. It is extremely important to go ahead and do your asymptotes first before anything else. We then continue on to any points that we may have. First would be our x-intercepts. So we have 0, 0, and we have 4, 0. The y-intercept is included within the x-intercept, so we don't have to worry about that. There are no holes. But it is extremely important to also realize that there is a cross at 3 over 2, 3. Keep in mind, that means that it would occur at this spot right there. It is truly important to realize that when something is crossing the asymptote, it needs to occur on an asymptote. So if for some reason you are calculating the cross asymptote and it does not end up on an asymptote, there's a very high chance that there is a mistake somewhere on the line, whether it was calculating the cross asymptote or calculating the vertical or horizontal asymptote itself. As we continue on, we go and begin to actually graph our different areas. Now, generally this is seen as 3 different parts. We have the left, the middle, and the right side. Now, using the points that we already have, it is very easy to determine what this graph is going to look like. But we need to know whether or not our points would be, or our line would be above the horizontal or below the horizontal. Keep in mind, our x-intercept does cross at 4, 0, and we're going to start with section 3. It crosses at 4, 0, which means our line would have to cross through that x-intercept. And there is only one way that it can look. As it's going towards the vertical asymptote of 3, it's going to continue to get closer and closer. And as we go further to the right, it's going to be stopped by that horizontal asymptote at 3. As we look at section 2, and we go ahead and determine what it is that this problem will look like, keep in mind our left side point is lower than our right side point. This means that it will increase from left to right. So as we go ahead, it will continue to increase. And as we get closer to that asymptote, it's going to continue to decrease. The last section, which we labeled as section 1, notice we do not have a point above or below. Now, the only way to be able to determine whether this would be above or below would be to take a look at our vertical asymptote, which is at -1, and pick an x value to the left of it. In this case, what we can go ahead and do is plug in a -2, and as we plug in that -2, it will give you a value either above 3 or below 3, meaning that horizontal asymptote. That will give us the easiest way to determine what this graph would look like. So as we go ahead and plug in -2 into our equation, we would say 3 times -2 to the second power minus 12 times -2 over -2 squared minus 2 times -2 minus 3. We'll go ahead and work this problem out. First thing we're going to do is square our -2. So this would be 3 times 4 plus 24 over 4 plus 4 minus 3. 3 times 4 would give us 12 plus 24 over 4 plus 4 plus 3 minus 3. In this case, we will end up with 36 over 4 plus 4 is 8 minus 3 is 5. 36 divided by 5 would leave us with 7 1/5. Or we can write this as 7.2. Now, it's extremely important to kind of understand the values that are coming about this. And as we go ahead, we're going to go ahead and place our point on the 7.2. So here, 1, 2, 3, 4, 5, 6, 7. Now we do see that our point in this case will be above our 3. So we know that it will come through, down, and close to the asymptote. Now, this allows us to have an understanding of what our graph is going to look like, but we still need to figure out our domain, verify that all of our answers are correct and are appropriate, our range and behavior, and one-sided limit. Based off of our domain, keep in mind, we still have a vertical asymptote at -1. We have a vertical asymptote at 3, and that makes our domain correct. We go on to our range. Notice it continues from -infinity to +infinity, and we do have a horizontal asymptote, so we do have to take that into consideration. Our horizontal asymptote is 3, which would usually mean that our range would not include the y equals 3, but we have a cross. Because a cross occurs at the 3 on the y, this means that it is included, and this would mean that we would have a range of y such that y is equal to all real numbers. Keep in mind, the only other thing that you could take a look at would be to see if there are any holes that would also affect your range. Now, let's take a look at our end behavior. Keep in mind, the end behavior will always go towards the horizontal asymptote. In this case, our horizontal asymptote approaches the 3. So we would go ahead and write this as the limit of f of x as x approaches -infinity would be 3, and the limit of f of x as x approaches +infinity would be, once again, +3. For the one-sided limit, in this case, every one-sided limit is always in relation to a vertical asymptote. Now, you have, for every one vertical asymptote, you approach from the left side as well as from the right side. In this case, we have 2 vertical asymptotes, so we are going to have a total of 4 different parts to this answer. Our first one-sided limit would go towards -1. So we would go ahead and write this as the limit of f of x as x approaches -1 from the left side. We would write it from the limit of f of x as x approaches -1 from the right side. Our other vertical asymptote would be for 3. So the limit of f of x as x approaches 3, +3, from the left side, and the limit of f of x as x approaches 3 from the right side would all be one-sided limits. Now here we have to take a look at what is going on as we approach from each one of these sides. Keep in mind, what occurs here is as we approach -1 from the left side, notice it is going towards +infinity. So as we get closer and closer towards the -1 from the left side, notice it is continuing to go up. And from the right side, as we continue to move towards the right-hand side, towards the left-hand side, and closer to our -1 from the right side, it continues to go downward. As we approach 3 from the left side, so as we approach 3 from the left side, notice we are going up, which would be +infinity. And as we approach it from the right side, it is going down, which would be -infinity. Let's go ahead and take a look at slide 6. Now, in slide 6, we go ahead and take a look at our equation of x to the third minus 9x over 3x squared minus 6x minus 9. First thing we would do is go ahead and factor out this equation. So as we simplify this out, this would be first broken down into 3 times x squared minus 2x minus 3, which fully breaks down into 3 times x minus 3 and x plus 1. Our numerator, we can factor out an x, which is left with x squared minus 9, which also breaks down into x and x plus 3, x minus 3. In this case, our x minus 3's do simplify, and we are left with a simplified equation of x times x plus 3 over 3 times x plus 1. Remember that this right here would be our simplified equation, and our original equation would be this on the left-hand side. Once again, there is an order to doing these problems. Our first thing that we're going to take a look at is our domain, and our original equation domain, remember, would be 3 times x minus 3, x plus 1. This means that x, such that x cannot equal -1 or 3. We would then go to the wholes of this equation, and in this case, we would take a look at what was simplified. In this case, x minus 3 was simplified, which means x would be equal to 3. We would go ahead and plug in the 3 to solve for the y value, and we would plug it into our simplified equation, which would be 3 times 3 plus 3 over 3 times 3 plus 1. This would be 3 times 6 over 3 times 4. Notice in this case, we can multiply it out and get 18 over 12. Or we can go ahead and just cancel off the 3's from the numerator and denominator. We'll go ahead and just multiply everything out. 3 times 6 would be 18 over 12, which simplifies to 3 over 2. Our whole in this case would be at 3 comma 3 over 2. Now that can be written as a fraction, or that could be written as a decimal. Just keep that in mind, whatever would be easier for you to be able to draw. We then go into our vertical asymptote. Now keep in mind our vertical asymptote is determined by the denominator of our simplified equation. There we had x plus 1 is equal to 0, which means x cannot equal, or x does equal 1. Correction, -1. So we would write this as x is equal to -1. As we go on to our horizontal asymptote, first thing, This could be a horizontal asymptote, or it could be a simplified slant asymptote. In either case, we have to take a look at the exponents. 3 is on the top, 2 is on the bottom. There is a difference of 1, and it is greater on the numerator than the denominator, which means this is a slant asymptote. We would go ahead and put none next to our horizontal asymptote, and we would go ahead and conduct the long division for our slant asymptote. So we would go ahead and divide x to the third minus 0x squared minus 9x minus 0, and that will be divided by 3x squared minus 6x minus 9. Now the entire goal is to make our first term coefficient match up with our first term within our division and have them cancel out. In this case, we would need to multiply by 1/3 x in order to have that happen. That would give us x to the third. And although we may not end up with perfect cancellations of our other terms, that is okay, as long as the first term cancels out, minus 2x squared minus 3x. Keep in mind, we are simplifying here and we are subtracting. So as we subtract our entire new number, keep in mind, we can distribute the negative, and when that happens, it will change the signs of the remaining numbers. We are left with 2x squared minus 6x minus 0. And once again, we repeat the same process all over again. In this case, we are going to multiply by 2/3. 2/3 times our number on the outside would give us 2x squared minus 4x minus 6. Now keep in mind, when that does happen, it will change the signs of all of those following. Notice our first two terms cancel out. We would be left with negative 2x plus 6. Now, the most important thing from this long division is the quotient. It is not the remainder. So in this case, our answer, our simplified answer, once all of the long division has been completed, is that our slant asymptote would be at y is equal to 1/3 x plus 2/3. Keep in mind, this is set up in the fashion of y is equal to mx plus b. We would then go ahead and determine the cross asymptote. In order to determine the cross asymptote, we would have to go ahead and set our, usually it would be our horizontal asymptote, equal to our simplified equation. But in this case, since we don't have a horizontal asymptote, it would be our simplified, our slant asymptote that would be put in its place. So we would go ahead, write this down as 1/3 1/3 x plus 2/3 is equal to x squared plus 3x over 3 times x plus 1. As we multiply both sides by 3 times x plus 1, keep in mind 3 times the 1/3 would leave us with a single x, or 1x, and 3 times 2/3 would leave us with 2. And that would be multiplied against x plus 1 is equal to x squared plus 3x. We're going to FOIL our left side, which would leave us with x squared plus 2x plus x plus 2, x squared plus 3x plus 2 would be simplified left side, and x squared plus 3x would still be on that right-hand side. We're going to bring our terms over to the left-hand side and subtract x squared and 3x. This would leave us with 2 is equal to 0. Now in this case, 2 never equals to 0, which means that there is no cross that occurs within this problem. We would then go ahead and solve for our y-intercept. Easiest place for us to plug in would be into our equation. Keep in mind, as we do that for the y-intercept, we can easily determine that in each one of our positions for our original equation, 0 times any type of number or to any type of power would give us 0, which means this would be 0 minus 0 over 0 minus 0 minus 9. 0 over negative 9 would just be 0. So our y-intercept would be 0, 0. Our x-intercept would also be 0, 0, but we still need to double check to make sure that we have all of the x-intercepts that we need. In order to do that, we go ahead and set our y equal to 0. As we do that, we would go ahead and write 0 is equal to x squared, x to the third minus 9x actually we can use that. Now you can use the original equation. You can either use it broken down and factored out to make your life easier, or altogether. Let's just go with it already factored out, which would be x times x plus 3, x minus 3, over 3 times x minus 3 and x plus 1. Now in this case, please keep in mind that whenever we multiply both sides of our equation by our denominator, anything times 0 would give us 0. So we would be left with 0 is equal to x, x plus 3, and x minus 3. As we solve for our zeros, this would mean x is equal to 0, x is equal to negative 3, and x is equal to 3. Now we've said it before, it's always important to double check that our x-intercepts are all there. Yes, x does equal 0. We were able to confirm that here. We were also able to find that x is equal to -3 as well as +3. Something to focus on is that x cannot equal a +3. And the reason for that is because we have a hole at x equals 3. So this is extremely important because now at that point, we cannot have a negative or a +3 as far as an x-intercept. So we go ahead and we would write down that location of -3, 0. We are going to go ahead and get started with graphing out everything that we have. We first start off with our asymptotes. In this case, our vertical asymptote would be at -1. We have a slant asymptote, which occurs at 1/3 x plus 2/3. So we start off on the y-axis at 2/3. And we would have a slope of 1/3. So we would go up 1 and over 3. And we would repeat that to get the slant asymptote. Now keep in mind, this is a dotted line because it is still an asymptote. We'll go ahead and write that down. Just in case. The points that we do have and do know about would be at 0, 0. We know that it would be at -3, 0. We also know that we would have a hole at 3, 1.5. Now, as we see these different points, we are able to easily tell, since we have only 2 parts to this graph, the left side and right side, our right side would go up and to the right-hand side. And on the left side, it would come down and through our x-intercept. Now, we must go ahead and once again determine that everything looks accurate the way that it does. We take a look at our domain. Notice we have a vertical asymptote at -1, and we have a hole at the 3. So notice that works out perfectly fine. In the case for our range, we would actually write our range as none due to the fact that it is a slant asymptote type problem. We would just go ahead and avoid the range altogether. For our end behavior, we would continue to write it the same way that we know how, which is as a limit notation. So the limit of f of x as x approaches -infinity, and the limit of f of x as x approaches positive infinity. Well, as we move to the left-hand side, we can easily see that we are going towards negative infinity. And as we move to the right-hand side, we are going towards positive infinity. For our one-sided limit, we have the limit of f of x as x approaches -1 from the left side, and we have the limit of f of x as x approaches -1 from the positive side. As we take a look at our lines, notice -1 from the left side is going towards positive infinity, and -1 from the right side is going downward, which means we are going towards negative infinity. Let's take a look at slide 7. So we're first going to begin with checking out the domain, but we need to see if we can simplify that problem a little bit more to get our simplified equation. So we start off with our simplified equation. We go ahead and simplify this problem. Once we factor out the bottom is going to turn into x minus 4 and x plus 3. Now in this case, our numerator and denominator will simplify out with the x minus 4. Our simplified equation will be 1 over x plus 3. Now, we already could tell that we were simplifying that x minus 4. So just so that you can kind of remember that we were using x minus 4, we'll put x minus 4 over here by the whole, right? So we're going to go ahead, we're going to go back to our domain. We're going to take a look at our entire denominator. We have x minus 4 and x plus 3. That means our domain will be x such that x does not equal -3, 4. And that is our first step. Once we figured out that first step, we're going to take our next step, which is going to be our vertical asymptote and our whole. So this would be step 2 right here. We're going to start off with the whole. Remember, what canceled out was x minus 4. So we're going to go ahead and get x minus 4 equal to 0, which means x is equal to 4. Since we have x equaling 4, we need to solve for the y of that point. In order to do that, you're going to have to go ahead and plug in your 4 into your simplified equation. So you're going to get 1 over 4 plus 3, which is 1 over 7. We're going to go ahead and take a look at our vertical asymptote. In order to do that, we're going to go ahead and take a look at that simplified equation, and we're going to look at the denominator of that simplified equation. What we're going to do is we're going to grab that denominator and set it equal to 0, which means x plus 3 is equal to 0, which means x is equal to -3. We'll go ahead to step 3, which will be our horizontal asymptote and slant asymptote. To begin with our horizontal asymptote, we're going to take a look at our original equation. Now, the one thing that I need for you to realize is that here we have the degree of the denominator being greater than the degree of the numerator. Whenever that happens, that means that our answer will be y equals 0. So our horizontal asymptote is y equals 0. Because of that case, our slant asymptote is going to be none. We're going to go ahead to step 4, which is checking for crosses. Now, in order to check for your cross, you're going to go ahead and get the horizontal asymptote, which in this case is 0. And we're going to set it equal to our simplified equation, which is 1 over x plus 3. We're going to go ahead and multiply both sides by x plus 3. That will cancel off the denominator. What ends up happening is 0 times anything remains as 0, so 0 is equal to 1. Now, anytime that we have a variable cancel out, and we no longer have any type of variables within our problem when we're checking for crosses, this means that it does not cross. You have to remember that when we are searching for the cross, we are searching for a point in which it crosses, which means if there is no variable, we can't solve for it. So this will not cross. So our answer is none. Let's go ahead and take a look at our next pieces. Our next pieces are going to be our x-intercept and y-intercept. So every time that we are working with the y-intercept, we know that we are plugging in x equaling 0. And every time that we are working with the with the x-intercept, y is equal to 0. So let's go ahead, start off with our y-intercept. In this case, our problem is 1 over x plus 3, which means we're going to replace x with 0. We're going to get 1 over 0 plus 3, which is equal to 1 over 3. Our y-intercept here is going to be 0 and 1/3. Now let's go ahead and solve for our x-intercept. We're going to do the same thing. We're going to go ahead and plug in 0 for y. Now when we do that, we're going to get 1 over x plus 3 is equal to 0. When we multiply both sides by x plus 3, what's going to happen is that 0 times that entire x plus 3 will turn it into 0. So it's going to be that 1 is equal to 0. In this case, because 1 is equal to 0, it does not happen, which means we do not have an x-intercept. So using all this information, we can go ahead and actually start graphing from this point. We're going to start off with vertical asymptote. So our vertical asymptote is at -3. That's usually represented with a dotted line on our graph. We're going to take a look at our horizontal asymptote. In this case, y is equal to 0. We're going to go ahead and start plotting any points that we know that we have. In this case, 0, 1/3. That would be right around there. We have a whole, which is going to be at 4 and 1/7. So 1, 2, 3, 4 and 1/7. And we also have a y-intercept at 0, 1/3, which we already put down. We have our whole, and that is just about it. Now, once we have gotten to this point, we're going to go ahead and graph what is going on for this problem. Now, we're going to take a look at the cross. We're going to take a look at the whole and our vertical asymptote. All of those different things are extremely important because it gives us an understanding of what's going on with the graph. In this case, notice we do not have any crosses, which means that this line that is over here and gets close to our 0 does not ever pass those asymptotes. Now, in the case of the left side of our asymptote, easiest way to figure that out would be picking a point to the left of that asymptote and solving for it. So what we're going to do is we are going to go ahead, we're going to plug it into our original equation. Here we have a number like 4 could be used, or sorry, -4 could be used. We're going to go ahead and plug it into our equation. So x minus 4 over -4 squared minus -4 minus 12. So we're going to go ahead and combine our like terms. This will turn into adding the opposite, which is -8 over 16 plus 4 minus 12. So -8 over 20 minus 12, which is 8, which is equal to -1. So our point over here is going to be -4, -1. Now the reason why we chose this is because currently at the moment, we do not have a point to the left-hand side of our vertical asymptote. So we need to find one. So you can choose any point. In this case, I chose -4, and we ended up being at -4, -1. Once again, we do not have any crosses, which means that this line will look something similar to this. From here, we have the ability to take a look at all of our different areas that we have remaining. We'll start off with the range. The range would be y such that y does not equal. Now let's take a look at our horizontal asymptote, which is 0. Notice the lines do not cross 0, so 0 will be part of the range. We have a whole at 1/7, so we will also have to take that into account. So y cannot equal 0, and 1/7. Let's talk about end behaviors. Best way to represent this would be the limit of f of x approaches something as x approaches negative infinity. The limit of f of x approaches something as x approaches positive infinity. Keep in mind, whenever we are working with our end behavior, we are going to look at our horizontal asymptote. In this case, our horizontal asymptote is 0. We can confirm this by looking at negative infinity, which would be over here. Notice we are getting closer and closer to 0. Our positive infinity would be this right here, which notice would be, once again, close to 0. When we're working the one-sided limit, notice limit of f of x approaches a number as x approaches, and we're going to go off of our vertical asymptote, which is -3. So we're going to go from -3 from the left side and -3 from the right side as well. So what we're going to do is we're going to take a look at the left and right side of that asymptote. We'll start off with the left side. As we work towards the asymptote, what is going on with the line? It is going down, which means towards negative infinity. On the right side, as we are approaching from the right side and getting closer to the asymptote, what's happening? We are going higher and higher up, which means this would be a positive infinity. This right here would be exactly how you would solve slide 7 as your problem for 8.2.